Hello, everybody. Thanks for joining. I'm Sean Noyes. I'm the Senior Cloud Solution Architect dedicated to Azure for Redis. And today I'm going to talk about Redis Enterprise and our partnership with Azure. So just a little background on Redis. Redis started as an open source database. Might be familiar with some of the projects that came about from Redis. It's extremely popular from an open source perspective and from an enterprise perspective among the community. We were founded as a company in 2011. We're a private company. It was raised a lot of venture capital, but we're effectively an in-memory open source NoSQL database. The key for Redis is that we are easy to use and that we are extremely high performance, as in low latency. So Redis frequently operates as a cache, and customers use it alongside their persistent data or their relational data. Part of what I'm going to be talking about today is our strategic partnership with Microsoft Azure, because we do have some really interesting things going on, and this partnership is part of a co-engineering effort between our companies. So as I mentioned, it started as an open source data project. So at its core, Redis Enterprise is the open source project that's running these shards of databases that are really at the core of it. It's the same version of the open source that's current in the community. But we have several different kinds of data structures. Now, that core of OSS has a bunch of data structures that people might not be really familiar with. We do a lot of things with geospatial data. We can do hyperlog. We also do stream processing. You can do pub/sub with Redis. You can do all different kinds of things aside from the usual things, which is storing strings or key value pairs and hashes. We also offer some extended data types in Redis Enterprise, such as JSON and probabilistic data structures. I'll get into those here in just a minute, but those are also available as an extension from Redis Enterprise. We're very focused on the developer experience, and we offer something like a workbench called Redis Insight that's available for free. It can give you insight into the keys that you actually have in your Redis. It can allow developers to try commands against their Redis databases just to get an understanding of what behavior they should be expecting in terms of the response. It's a very handy tool. And we also support client libraries across a bunch of different languages. There are almost 100 client libraries for Redis. A lot of those come out of the open source community, but the ones that are supported by Redis, the company, are under .NET, Java, Node, and Python. Redis Enterprise also has these data processing engines. I mentioned the ability to manage streams. We also have a very, very efficient query and search module that I'll get into here in just a minute. And we're also right now in preview in Azure doing an integration with Azure Functions, whereby changes in the Redis database can trigger Azure Functions and take things like write through and read through, write through, and write behind away from the application logic. So it's a really exciting feature that we're currently in preview with in Azure. All of this comes as the enterprise grade capabilities that you would expect from any enterprise software. It's deployed default in an HA stance. We have linear scalability. You can do backup and restore operations. We also have geo distribution, which I'll talk about in a second, tiered memory access, and we have multi-tenancy, which is coming in preview in Azure. And of course, we have a pretty firm security stance for Redis Enterprise. So again, a lot of people might be used to thinking about Redis as basically that key value store where you can store user sessions or you can store content, but there are all kinds of other use cases which customers use Redis. We have a time series module, which is very effective for storing time series data and managing aggregation. I mentioned pub/sub, but we have companies who use it for things like fraud mitigation and leaderboards. It can be a machine learning store, an online store. Again, that geospatial data type is very special. And again, very low latency in terms of the response. So getting into what we offer with respect to Azure, there are 5 tiers available in Azure. There's Basic, Standard, and Premium, which are effectively forks of that open source project that I mentioned. Now, Enterprise and Enterprise on Flash are part of that joint engineering effort that we have with the Azure engineering team. So we have built this service, which is a fully managed service on Azure, to provide that enterprise level of service above and beyond what Basic, Standard, and Premium currently do. So we have a higher SLA, we have much larger workload sizes, we can do different types of scaling, and we offer those extended data modules, which I already mentioned. But this partnership comes together to allow us to extend those features that I just mentioned, and we offer joint support with Microsoft. So effectively, Microsoft, the Azure support team, takes the first call, and any tickets that are submitted from the customer land on that team. And then if there is an issue or if there is additional support required, our support team can step in on escalation to assist the customer directly. So it's a very seamless relationship in terms of how we're working together as a team. It's not just a co-engineering effort. We're also doing that co-support effort. And with respect to administration of the accounts, everything's integrated into Azure. So you don't really have to engage with, Redis account teams. You can do all of this self-serve through Azure Portal. Obviously, you can talk to Redis anytime you wish. Again, but the point is that it is really a single team. When we're talking about Redis Enterprise, the Azure team and Redis are working jointly together. So I keep mentioning Redis Enterprise, and I've said it's different, but it probably helps to just look at a graphic and kind of understand. So at its core, again, that Redis open source database is part of the Redis Enterprise software package. However, on top of that runs several different types of software. One of them is akin to like a Kubernetes control plane, where we do cluster governance. We're orchestrating failure. We're detecting when there's failure. We're doing failover into nodes that are healthy, and we're healing nodes that are unhealthy. This software that runs on top of that Redis database is managing that entire cluster on your behalf, and is part of what makes that managed service so powerful. There are a couple of other things that are happening here. We also have, the ability to interact directly with the API, but there's a special thing here that is the proxy that is running on Redis Enterprise. So with Redis open source, might not know it or might not care, but the shards, each of the shards in that database are single-threaded shards. So as you scale out, you're still bound essentially by however many threads you have available to those, because every Redis process is single-threaded. The great thing about this proxy that runs on Redis Enterprise is that it does multiplexing and pipelining of commands that come into the cluster to take advantage of extra threads that are available within the VM on which that node works. So a cluster, which would be multiple nodes, would have failover nodes, and it would have these things, but all of that traffic is going to come through the proxy layer, and that proxy is going to be streamlining all the communication within the cluster itself, so that we don't have back pressure on the network and we don't have issues with the threads themselves. So one of the other features that we have, I mentioned dynamic tiering for Redis Enterprise, and what that means is we offer effectively an extension of DRAM with SSD. Now that is not a persistence layer onto SSD. That is really an extension of DRAM. As you know, DRAM is very expensive. It's very fast, but it is expensive. And in very large data sets, you can extend that capacity with SSD and take advantage of it. Right now, we're offering cache sizes up to 13 terabytes. And it has 70% lower prices per gigabyte. And the way this works is that Redis will keep all of the all of the keys within RAM, and then it will maintain visibility to how often keys are used. So it considers some of the data, the values of those keys to be hot and some of them to be warm. And it will keep the hot data in the RAM where it can be accessed with the lowest latency, and it will move off the other data into the warm side, which is going to be slightly slower with SSD. So this is a great cost and performance trade-off when you're looking at these really large data sets. I also mentioned geo-replication. We offer geo-replication within the Azure service. You can join Redis databases from disparate regions, and you can give the local users local latency while maintaining the data across those clusters without any application coding at all. In the event that there's a regional failover, you can fail over using some kind of load balancer, global load balancer, and push all the traffic to the region that's still available, and the data will still be there. It offers greater resiliency, and it's obviously more consistent in terms of data. The technology is very fascinating, and it is available again globally. So I mentioned the several enterprise extended data structures for Redis. So one of these we have is a probabilistic data structure called Redis Bloom. And that's a probabilistic data structure that will tell you whether something is probably in the cache or definitely not in the cache. And of course, you can tweak the settings on this type of search depending on how accurate you need it to be. But it's a really effective way of finding out very, very quickly whether or not you have the data. The common use case for this would be fraud mitigation, where you can see definitely for sure whether or not an IP address, for instance, has been accessed, or whether it probably has been. So you can design your application code to take advantage of that initial hit, which is very quick, and then decide from that response what you can do, which actually might add a little bit more latency into the chain. I mentioned time series as well. Now, time series data is very difficult to deal with. If you've ever tried to model time series data in relational databases or even in NoSQL databases, you end up having to do something where you're having to make it human readable and aggregate that data as you have lagging data coming in. The great thing about Redis time series is you can set up the time series data so that it does aggregations on the fly. So whenever new data comes in, you have a new key which is created, which you can access, which will give you that data. Or you can also have a human readable type, which actually aggregates things and sums and averages things over time. So these kinds of processes, which would have been, required several batch processes to rerun every time there's lagging data, don't have to be rerun again. You can just immediately access that data, access the aggregation, make it human readable and human analyzable. Redis Search is our most popular module, and Redis Search is great for indexing and querying data. It offers a lot of different ways of doing it. Multi-language support. You can do stemming phonetically. You can, build your own search engine from within Redis and take advantage of that extremely low latency. It's very powerful and very popular. And really, kind of alongside that is a newer type, which is Redis JSON. And Redis JSON allows you to store entire JSON documents within Redis. Well, you could do that with a string, sure, but the great thing about Redis JSON is it allows you to query parts of that document and return just that data so that you don't take the hit of serializing and deserializing the entire payload up and down the wire. In addition, you can also edit in place individual pieces of the JSON that is stored from within Redis so that you, again, don't take the hit within your application of serializing and deserializing that data. So one last thing I want to touch upon, because I know it's very popular.
Hey, Sean, we've only got about a minute left. We know vector data is important, but I want to keep things moving. So if you could just be sensitive to the time constraint.
Yeah, absolutely. Yeah, this is my last slide, so we're good. So Redis Enterprise alongside Redis Search has offered vector similarity search as a function for the last few years. It's considered a mature product. We have a lot of customers who use it in production, and right now, obviously, customers are depending upon this. And Redis is an excellent choice if you are going to do vector similarity search, by virtue of the fact that you can store all of that metadata from within Redis as well and get back your search response at an extremely low latency. So I suggest, if you have teams that are getting into AI ML, that you look at vector similarity search from within Redis as a solution. And with that, I would just like to thank you. I appreciate your time today. Everybody, have a good day.